and thanks for that introduction. As mentioned, I'm Shawn Azman, the head of customer operations here at Vidora. And a quick background on myself. Over the last 10 years, I've worked in the consumer data space, from mobile analytics to marketing automation. And now currently, I'm at Vidora, where we help customers build automated machine learning pipelines. And I'm happy to say that over the past few years, I've had the pleasure of working with Ascend on numerous projects across multiple customers, and can say I'm very honored and excited to be here with you all today. And so with that, let's go ahead and hop right into the presentation. Today, what I'm going to be talking about is data automation, and specifically how data automation relates to machine learning. In working with customers here at Vidora, we find that the most successful customers are those that really embrace automation. And I'd love to share a few of those stories and also talk about how machine learning and automation really should be thought of as going hand in hand. In the presentation, I'm hoping to cover a few things. First is to start with a high-level overview of what machine learning is, but really also to talk about some of the difficulties inherent in building machine learning models. We'll then spend some time focused on real-time machine learning, which is a topic that we're finding a lot of our customers are extremely focused on right now. And finally, I'll end with a walkthrough of some real-world case studies to show how we can derive value from automation and machine learning, specifically with B2C companies. So let's get started. One conversation that I find I have with customers all the time is how we can create value on top of the investments that are already being made in the data architecture and data automation side of the business. I often think of these conversations as being summarized with, how do I create additional value from the data that I already have? And I feel that currently we're in a world of data overabundance. I feel like every company is probably asking similar questions, thinking that we have more data than we know what to do with. So I want to use this presentation to show how machine learning can be a natural way that we can gain existing value from the data that we've already been capturing. So very briefly, let's just talk about what is machine learning. And specifically, I'm going to focus this presentation on machine learning that can be derived from first-party consumer data for B2C companies. And we can think of machine learning simply as a transformation of the existing data that we've captured into predictions. And so here we have a very simplified example of capturing online user behaviors. And the goal is transforming those behaviors into predictions about those customers and their future behaviors. A few predictions that we can make are based on the activities that customers have done in the past. Which of them is most likely to purchase, most likely to subscribe? Or one example that I'll keep coming back to is, which of our customers are most likely to churn? And as we know, dealing with data can be quite difficult, and data can be extremely messy, in fact, very messy. And when we think about machine learning, unfortunately, having data in its raw form is not very useful. One of the first steps in the machine learning pipeline after we've captured this raw data is to transform that data. We need to put it into a format that is being expected by the machine learning model so that it can train and create accurate predictions from that data. And when we start to dive into these different data sources, one of the things is not all of the data that we've captured is good data or accurate data. And I can bet that there's not a person here who hasn't heard the term garbage in, garbage out. And nowhere is that more true than with machine learning. The models that we're going to train are specifically learning on the data that we give it. So if we give the model data that is wrong, inaccurate, malformatted, then we can't expect the predictions that it generates to be accurate. So we really need to make sure that when we're handling this data and transforming it into the format needed for the machine learning models, that we're doing it accurately. Otherwise, our predictions will be wrong. And unfortunately, this problem only gets worse once we realize that we have many different data sources that we're going to be dealing with. For customers at Vidora, we find that an average integration when creating machine learning pipelines consists of, on average, 3 to 5 different data sources. This could be website data, mobile data, subscription data, item catalogs, content catalogs, and the list can go on. So we have all this data from all of these different sources, and going back to our original question, how can we derive more value from this data that we've already been capturing? And that's what I'm going to talk through for the rest of the presentation. So when we think about automation and machine learning, this is a diagram that hopefully ties those two concepts together. We have the idea of capturing raw data, and the end goal is to derive business value from that data, and machine learning is the path that can get us there. The first thing that we need to do when building our machine learning pipeline is ensure that we're capturing clean and accurate data. And that's where it's great that we're partnering up with Ascend to make that process as easy as possible. Next, we need to transform that raw data into the format needed to train and for these models to learn. And once we have a model that is making predictions about our customers, we need to determine what business decisions are we going to automate with the output of those models. And it's finally then when we can start to realize the value from all of our efforts. And to be clear, this is not a simple process. And ideally, this is a process where each individual step is automated, but also the entire process is automated. We want to make sure that we're continually capturing data, creating predictions, using them in production, and then keeping that process going so that our models are continuously running and always being updated and always training on the most recent data. So if we zoom in specifically on the machine learning pipeline step in that process, we could probably spend an entire presentation talking about each of these steps individually. Data processing is probably something that all of us are doing. Again, we probably have an overabundance of data that we've already captured and processed. Now the question is, what should we do with it? And as we've talked about above, it's not enough just to capture that data. We need to make sure it's clean data so that we're training the models on accurate data to make accurate predictions. Feature engineering is a step that I'm going to get into, which is that transformation step of taking raw data and converting it into data that we can use to train our model. The final step, often referred to as auto ML in the space, is where we train many different models trying to find the most accurate model to predict our customer behaviors. But as mentioned, I want to focus on one of these steps in particular, which is feature engineering. And I think this quote by Andrew Ng really sums up one of the difficulties in real-world machine learning, or as he calls it, applied machine learning. And specifically, that is feature engineering. I've mentioned it a few times, but in order to train a machine learning model, we need to feed it data in a format that is being expected by the model. And it's this specific transformation that we call feature engineering. And this is something that I've talked with customers about countless different times. And it's one of the hardest processes in creating machine learning pipelines. I've heard estimates ranging from this process taking 2 months all the way up to 6 months. And that's just for coming up with a feature set in order to train one model. It's not all the way through the trained model, all the way in production. It's simply just giving us the ability to train a model, and even that step can take months. So why is this so difficult? It's difficult because there are countless ways by which we can transform that raw data into a feature set that we use to train our model. So going back to one of the prediction examples that I gave before, let's say that we were trying to predict whether or not a customer is likely to churn over the next month. Some questions that I'm going to ask myself when creating these features. One is time windowing. So how far in the past am I going to give the model data in order to learn? Is 1 week's worth of data enough? 1 month? Do I need to go back a year, even longer? And then once we've determined what time frame we want to look at, we have to determine what data we want to create features on within that time frame. Is it enough just to look at the high-level actions that a user is taking on the site, your clicks, purchases, subscriptions? Or do we need to also look down deeper into the data, look at the metadata and additional parameters that we're capturing of all those events, and use that to train the model? And finally, if we've determined the time frame, we've determined the data set we want to featureize, how do we know which of those features is best to give the model in order to achieve the highest accuracy in our machine learning pipelines? All of these questions are quite complex and can take months, as we've talked about before, for individual teams to solve. So let's look at some real-world examples of how this could work. Let's first look at a media company. And this will help us illustrate what the output of this transformation can look like. On the right-hand side, we have Vidora's product, which is just a demo data set, so this is not a specific customer, but it's exactly these kinds of steps that we use with all of our customers when creating new features. And a few things that I wanted to highlight specifically. If we look at the top of the screenshot, we're looking at event types. And this is probably the most common feature engineering technique that we use for first-party consumer data. A few things that we can do. The first and most obvious is to count the number of times users have done each of these actions over certain time periods. And what we can notice is that we're using different time periods in order to learn different things about these customers. So how many times have each customer watched a video over a 7, 14, 30, 60-day period? And we can also use feature engineering techniques not just to do counts of how many times users have done certain actions, but we can also look at the derivative, or in this case, the delta. What's the change in frequency of users doing these events over a period of time? Did they do it more at the start of the 60-day period than they did at the end? And then if we look further down on the screenshot, especially for media companies, one of the most important things is not just knowing that a user watched a video or read an article, but understanding the context of that content that they're consuming. Here we see that as content categories. And one of the questions that we can ask in order to create these features is, over that given time window, what % of all content consumed by this customer was from a specific category? Are the majority of the views that this user did in the sports section, the news section, the business section? And it's really by understanding these additional parameters that we can start to better understand that customer. And I wanted to show another example from a different industry, specifically a commerce example. And so 2 examples that I wanted to highlight here. First is the item category. Very similar to media, but here we're looking at the actual products that a user can be interacting with. And so are they purchasing pants, jackets, shirts? And over a certain time period, how many of those items have they purchased? What % of their purchases were in each category? And then lower down, we can also see event types. Again, tracking how many times users take certain actions within the site. But really what I was hoping to draw from these 2 examples is the commonalities used in creating these features. While the data is going to look very different between a media company and a commerce company, the way that we create these features is very similar. We could create features on the events where a media company, those events might be read an article and watch a video. The commerce company might be add to cart and purchase. And when we're looking at content from a media company, it'd be very similar to looking at categories and departments from a commerce company. So while there's 2 different companies, 2 different data sets, the techniques for creating these features can stay consistent. And this is really where the idea of automation really comes in to helping create these machine learning pipelines. And it's a huge value if this specific step in the machine learning pipeline can be automated. Instead of taking 6 months to create this feature set, with an automated step, we can do this in hours or days rather than months. This leaves us time to focus more on the business questions that we're trying to ask and focus less time on the simple management of that data. So going back to the automated machine learning diagram that we saw before, it's really through automation where value here is derived. We just discussed one step in this entire process, which is feature engineering. But hopefully that example shows that this process is only as fast as our slowest step. If the feature engineering step takes 6 months, then getting value from our machine learning efforts at minimum is going to take that 6 months and probably longer. So ideally, every step in this process is automated. We're automatically generating new data, feeding that into a machine learning pipeline, deploying it and automating our business decisions, and then continually capturing data from that point so that we can retrain the model and have more decisions be automated from that. The benefit of having each of these steps automated is quicker testing and quicker iteration. If we can create new models in days or weeks rather than months, we can create more models, we can iterate on the models that we've already created and test the different automated decisions that we want to influence from those models. And the reason this is valuable is that we can start to derive value from that data that we've already captured much quicker and much easier. So up until this point, mainly what we've been talking about is how to capture data and use that to train a model. Sadly though, building a model is only half the battle. We've seen stats fly around that say upwards of 80% of internal machine learning projects never make it into production and therefore never derive value for a company. So why is it so hard if we have a trained model to actually get it into production where we're seeing that value? One of the things that we've seen is it comes down to the skill sets needed for each of those steps. Building a model is something that requires machine learning expertise. We need somebody who knows the data, knows how to create features, knows which models to test. And however, a lot of this testing when done internally for a company is done locally. And so we'll get a subset of the data, we'll use a subset of that data, which is static, to train these models, and the output of that will be that trained model. However, once we have that trained model, the idea of deploying that into production usually takes a completely different skill set. There, we need somebody who understands our data architecture. We need somebody who knows how to deploy these solutions at production scale with millions of users and billions of events. And if we're going to get into real-time machine learning, we need to know how this works at production speed. So one suggestion is, if we're looking to deploy machine learning in-house, make sure that we have expertise on both the data science side as well as the deployment side. So now let's transition into assuming that we have a trained model, how best to get value from that in production. The first question that we want to ask is, how do we want these predictions to be generated for the use case that we're trying to affect? Two common examples that we work with on customers. The first is batch machine learning, where we want to get all predictions for all of our customers right now. We often see this used mainly for offline use cases, oftentimes with marketing segmentation or personalization, or for ad targeting. We want to create predictions for all of our customers, and then in aggregate, use those in a campaign. Another way that we can derive value is through real-time machine learning, where we want to update the prediction values for our customers in real time as they're interacting with our brand. We often see this used by product teams doing on-site personalization. So that could be content or item recommendations or a next best action. And it's my view that automation is really required for both of these use cases. Even if we're doing batch machine learning where we're updating predictions for all of our customers at one time, we need that process to be automated. Otherwise, every campaign we run needs to wait those 2 to 6 months for that process to be completed. And real-time machine learning really does require automation in order to continuously run, continuously make predictions about our customers, and do that all within milliseconds on site. And one of the key things with machine learning is to not think of it as a one-time process. If we have a trained model today, how long into the future will it take for that model to go stale, where the user behaviors have changed so much that the predictions aren't accurate anymore? And so automation ensures that as we're capturing new data, We can continually retrain that model, so any changes in the product, any changes in user behavior get built into the model and predictions are updated accordingly. Specifically focusing in on real-time automation, as I have a few use cases that I'm going to show here in a second, this can really only be accomplished through data automation. And the key with real-time machine learning is understanding what the customer is doing right now and using that information to update predictions about them. And there's a few steps of automation that are required to make that happen. First is all of those feature engineering techniques that we talked about earlier in the presentation. These now need to happen in real time on the client side as the user is engaging with our brand. And not only that, but if this is a return user, we have historic information about them outside of their current session. So we need to fetch that information and include it in the prediction. After these data sets are combined, we need to generate a prediction about that customer in milliseconds so that we can update the site accordingly. Without time for human intervention, this process can only be accomplished through automation. So I wanted to end the presentation by talking about a few case studies and examples where machine learning and automation can derive value for customers. One of the most important things, and I think underappreciated things about automating machine learning, is how it can really open up access to many different teams in an organization to use machine learning. We've often talked with companies where because it takes so long to build even just one machine learning model, the number of teams who have access to use machine learning is very limited. We've probably all gone through this where we have a prioritization of requests and maybe where the marketing team, and we're looking to improve our churn win-back campaign by using machine learning to predict the best segment audience for that campaign. But if we're not prioritized at the top of the list, we may then have to wait all those months for these other models to be built first before our model is built. However, if we have automation that's helping us in this machine learning process, we have the ability to create more models, test more models, and really open up access to many more teams because the process is that much quicker. So if it only takes days to create new models, we can work with the product team, the ad tech team, the marketing team. Everybody can have their requests prioritized because it's no longer taking 6 months to create that model. So in the next few use cases, I'm going to focus in on real-time machine learning, where we're creating predictive models using both data generated in real time in session, as well as any historic data we know about that customer. The first is how do we maximize customer lifetime value? Each customer can take a unique journey through a product and with a brand. So it's not always clear what path we should be directing that user in order to maximize their lifetime value. One way to know which path to choose is by using real-time machine learning. And the process outlined here on this slide is going to break it down into 3 different steps. First is to define the key conversion points in the funnel for that customer. Here, in this example, we can entice a user to register, save a search, or perhaps download the mobile app. And the second thing is to define a value weight for each of these conversions, as some of these conversions may be worth more to us than others. And the third step is to create a machine learning pipeline that runs in real time to predict the likelihood a user will convert on each of these different actions. So to answer the question, which path should we direct a user down? It comes down to what's their likelihood to convert on that action times the weighted value of that conversion. For some users, the LTV may be increased the most by getting them to download the mobile app. Others, it's getting them to register their account. And these predictions can be done in real time. And the final use case that I'm going to talk through is actually a use case which was done in partnership with Vidora and Ascend and the New York Post. Really quick background. The New York Post recently released a new sports subscription service. And we worked together amongst our 3 companies in order to find a way to maximize conversions to that service. There were 2 main questions that we were trying to answer. First, which customers should we target with the flyout promo informing them of this service? And then second, if we are going to show the promo, which message should we use in order to maximize conversions? This slide that we're seeing here is focused in on that first question, which is which users should we target? This was done with real-time machine learning. And by using all of the in-session behaviors combined with all of the historic data, we were able to see a 3x increase in conversions. And this type of real-time targeting is crucial, especially for media brands where we see a large majority of customers on site are anonymous users or users without a registered account. Without any historic data, the only data that we know about that customer is the data that they generate in real time in that session. So once we've determined the target audience who is best for this flyout, the second question becomes, which message should we show? This is an extremely common question, especially for marketing teams. When we have the ability to communicate with customers and we have multiple messages, maybe multiple offers, multiple promos that we can use. So how do we match the right message with the right user group? Using the same type of real-time machine learning as the previous slide, we were able to see an increase in subscriptions by 40% by matching the best message with the best user. And these two use cases couldn't have been accomplished without automation, where we're automatically generating the features, combining it with historic data, and generating predictions within milliseconds. And that brings us to the end of the presentation. So in summary, wanted to highlight a few of the areas that we've gone over, which I think highlight why automation and machine learning should be thought about hand in hand. First, for machine learning to be accurate, we need to continually collect high quality streams of data. That's why it's great for us to partner up with Ascend in order to help multiple of our customers with this step and do so seamlessly. Once we have the data, as we've seen, creating a machine learning model can take months for some companies. But if we can automate every step in creating that machine learning pipeline, we can cut that time frame down to days. And we can just think about how many more tests we can run, how many more models we can create by having that process automated. Finally, deploying machine learning pipelines into production also requires automation to run at scale. We need these models to run continuously in real time for millions of customers, and this is not an easy task without data automation. And I hope that everybody found that presentation interesting. If anybody has any questions, you can feel free to reach out to me after, but I know that we also have some time set aside for Q&A, so I would love to hear any questions that you all have. Please feel free to reach out, and I think we'll take some of those questions right now.